Hi, everyone. Just wanted to welcome you all to the Learning Labs. We're going to get started in a few minutes. If I would love to hear where people are from and if they've used Chainguard images and containers before. I'm calling in from New York. Hello, UK. Is it after work for you in the UK or almost just? Almost done. So we'll give it a little bit longer. Treadmill time. Do you have a treadmill desk? I know some people at Chainguard have those, and it looks like they're very active during our meetings. Cool. I think we could probably get started now. So thank you everyone for joining the Chainguard Learning Labs. Hello, Lincoln, Nebraska. We are going to have Adrian, who is a staff developer relations engineer at Chainguard, talk to us about static container images. And Adrian is a container genius, so you're in very good hands. And I also want to just share with everybody here that we have a Chainguard community Slack today, and I'll put the link in the chat after I'm done speaking. So if you have any questions following this learning lab, please feel free to jump into the containers channel or really any channel there, and some people from the Chainguard team can help you out. So without further ado, I'll hand it over to Adrian.
Thanks, Lisa. As per usual, I'm struggling to find the share my screen button. Oh, there it is. I think I've got it. This looks good. So hopefully people can see my screen. Am I right?
Yes, looks good.
Good. I have, because of the way I've set it up, I've lost everybody, so you'll have to shout at me if there's questions or whatever. Okay. Anyway, yeah, welcome everybody to Learning Lab. I'm in the UK, so apparently I'm still working. Just to give a little bit of background, what we're going to be talking about is building secure and minimal minimal images with Chainguard static images. It is a fairly high-level talk. The only real assumption I'm going to make is that you know Docker, or maybe a little bit about Docker. You can do Docker run and Docker build. If you want to follow along with the demo, you will need to have a system that you can run Docker on and a text editor and access to Git, but that's about it. Okay, let's hope I can change my slide now. There we go. Yeah, so my name is Adrian Moe. Lisa's already introduced me. If you do want to get in touch, I am on various social media. That QR code is like in all my links, so you can find them all in one place. But yeah, I'm on Blue Sky probably more than X now, and also LinkedIn. So what we're going to go through today, I'll start with a brief introduction to CVEs or vulnerabilities and what they are and kind of what they mean for software development. We'll talk a bit about Chainguard images, so what Chainguard images are, how they address the CVE problem, and then we'll basically go straight into the practical. And in the practical, we're going to have an example image and show how to migrate it to sort of the Chainguard equivalent. During that process, we'll talk about multi-stage builds and how that gets us a bit further, and before a bit of a wrap-up. We've also got a bit on debugging images. I think Lisa already said, but it's a Q&A in the chat, so please do drop questions there as we go. I can't see them at the minute, so maybe Lisa or Allegra will stop me at some point, and if there's a few questions piling up. But I will also try and stop at various points to take questions. If you're following along during the demo and you get left behind or stuck, please let me know and I'll try and help. So yeah, if you want to follow along, you need Docker installed. Things like Podman should work. I've not tried it with the Apple containers thing. I should do that. I'm kind of hopeful that should all work because it's all pretty basic stuff. Yeah, basic container knowledge. If you've done Docker run, you're going to be fine. If you want to do the demo, you'll need to have Git to check out the code. So CVEs. CVEs are common vulnerabilities and exposures. It always trips people up. Like, people always forget what it stands for, but it's common vulnerabilities and exposures. So essentially, known software flaws that have a security impact on applications. Sometimes they can be really, really significant. So you've probably heard of things like Heartbleed and Log4Shell. And so the rise of CVEs led to the birth of some security tooling, so things like Trivy and Gripe and Sneak and Wiz. And all of those products, part of them at least, will help scan your code base or your container images, etc., for known vulnerabilities, and will produce a report on what they find. So the ideal, and I guess what was intended at the start, was people would be able to scan their source code of the images, get a report of the vulnerabilities, and fix them. But in most cases, that isn't really possible. And the problem is, a lot of the base images, things that everybody builds on, like the base images on the Docker Hub, they already contain CVEs. So before you even added your own application code, you've got a bunch of CVEs in your image. And it kind of leaves people in a difficult situation because they're not really sure what to do. They'd like to get rid of the CVEs, but they don't really know where to start. And that's where Chainguard comes in. So Chainguard's mission is to be the safe source for open source. We want you to be able to come to Chainguard whenever you want to use open source software in a secure and verifiable manner. So we have well over 100 customers across various industries, including various heavily regulated industries, such as defense and healthcare. The main product we have is Chainguard images. So these are minimal, security-hardened container images with 0 CVEs. So we sort of directly address the CVE issue. We've created over 1,700 images, I believe, in response to customer demand. So these are all things that people have asked for. We build images daily, and we have images for all your ecosystems, all the sort of programming languages, or at least common ones like Go, Python, Node, etc. And we also cover third-party open source, so things like Postgres, Nginx, and Redis. We have both FIPS and non-FIPS images available. If you don't know what FIPS is, don't worry and be very thankful, quite frankly. But if you do work in like FedRAMP or something, FIPS is very important, and we can definitely help you there. So here's like the selling point in a nutshell. If we compare the Chainguard Python image to the Docker official Python image, this is the results you get. So this is, if you go to images.chainguard.dev, you'll be able to run this yourself, and you can also run it against different images and compare to different images to see the results. But on the left here, where you see CVEs by severity, we've got the Chainguard image showing 0 vulnerabilities. And on the right, you've got the Docker official Python image showing considerably more than 0 vulnerabilities. I think I updated this morning. Yeah, I can see it goes up to 29 September, so I did remember to update this. So this is from today. The other thing to note, as well as like the large CVE count, is the size. So the size of our Python image is much smaller. Now, there are reasons and issues there. For like the upstream Python image will include a few more build tools that are not in our image, in which case you'd use the latest dev image, but still a huge saving in size going on there that you can use for your runtime image. Okay. So the natural question now is, why does the Chainguard image have so many less CVEs than the official image? And there's a few things. First one is our images are really minimal, right? We only include the packages and dependencies that are required to run the applications. So for production images, that will typically mean even removing the shell and package manager, because you typically don't need that for your running binary or whatever. By having small images with less software, there's simply less software to have CVEs. The second point, and what I think is actually the most important point, is we are constantly rebuilding from source. So when an upstream project releases an update or fix, we'll typically get that on the same day and have an updated image in a few hours or so. And if you compare that to something like the Debian image on the Docker Hub, you're going to need to wait for the Debian project to update the repository with the updates, which can take days or weeks. And then you also have to wait for the Docker image we built with the updated version, which again, likely takes several more days. And the third point is we will investigate any CVs that we find and issue security advisories as appropriate. So for example, if we find a CV is a false positive, we can flag it as such, and the scanners pick that up and won't report a CV in our image. Okay, I'm going to jump straight into the practical. Is there any questions at the minute? Jump back to see something in chat. Oh, just Lisa. Great. Cool. Right, let's see if I can figure out the sharing again. And I'll see if I can find my terminal. Oh, there we go. Okay, I'm hoping this is big enough. Maybe I'll make this thing. There we go. Hopefully that looks okay. I think so. Right, where am I? So we have a fairly simple practical here. Oh, I'm getting like an echo. There we go. So we've got a fairly simple image here. This is not using Chainguard at the minute. All we're doing is we have a very simple Golang project. I could build it. We could, build it and run it here. I'm slightly worried I'll get the syntax wrong. Oh yeah, sorry, I should have linked the code. I maybe have let me drop it in the chat. Of course, I can't paste from my thing. There we go. Oh, there's a errant new line there. Maybe not. Is that there? I've done it twice. Okay. Hopefully that URL will work. I think I just mucked up the URL. I don't think it was the wrong URL. Hopefully that's working. They were trying to move some of our good. We were going to move some stuff to Chainguard-demo, but I don't think that's happened yet. Okay, so you can go and check out that code. In there, you'll find a Go project with this Docker file. The Go project's very simple. You'll see it in a minute. It's basic. Well, we can take a quick look. Where is it? So there's a CMD, very little in here. It's just calling app run server and server.go, which is just setting up a web server that returns hello world. So that's all that's happening here. Okay, so the Docker file, this is using the Golang image from the Docker Hub. Oh, I should have copied and pasted this. Is that what I want? I hope so. I built it before, so that's very fast. If we run it, 80, stay, and put 80, I call it lab, and then I've mixed something up. Oh, because I got something else running. That's my bad from working through it earlier. Right. So, and there it works. So we have this image, it does work. So we think we're good, but if you look at the image, 1.37 gigabytes, which isn't great for a very small application like this. Worse than that, if I do gripe, you can see I've got the latest version. And yeah, so the problem is we do find some CVs, quite a lot of CVs of various levels. And I'm not quite sure what goes on here. It says 329 vulnerability matches, but then if you try and add up these numbers, it clearly adds up to more than 329. I'm not quite sure the reason why, to be honest. Yeah, maybe it's 329 individual CVs, but some of the CVs appear in multiple packages. I'm not quite sure. But anyway, quite a lot of CVEs in this image. No critical, but there are 17 high. So a little bit worrying. In some cases, you can see, like, for example, here, Debian have issues like a won't fix. So there's probably something that means that this CVE isn't really relevant. In other cases, though, you'll find, like, here's a high that's probably just waiting for a fix. Okay, so that works, but it's a little bit worrying. It's a very large image and it has CVEs. So what can we do? Oh, and I've just missed an E. So we're just going to change from the Golang image to cgr.dev/chainguard-go. It's the only change I'm going to make right now. And if we build that, well, let's go back to the old build command. And we'll call this something else. Okay, again, that was quite fast because I had a cached version from earlier. But if I run it, and I've probably still got the old one running. If I run it, should be exactly the same. Yep, so it works. But now if I do Docker images, well, it's still going to be a large image to be honest, but will hopefully be a little bit less. So 1.22 gigabytes. So a little bit less than, well, depending on whether or not 100 megabytes is a lot to you, or 150. So a little bit less than the image from before. But more interestingly, what happens if we do gripe? So one thing you might notice them for is there's just less, a little bit less in here. So 72 packages, 216 executables, but most importantly, 0 vulnerabilities. It's probably worth comparing how many packages and executables if I can scroll up through all the mess of CVEs. Yeah, so there's 220 packages and over 1,000 executables in the other image, and there is quite a lot less in this one. Okay, so that's actually a pretty fantastic result from like changing one line. So by changing one line, we've already made a big difference, but we can do better. And this is the bit I really want to talk about. This is where it gets a little bit more fun. So we're building with a Chainguard Go image, but the image we end up with still has the Go compiler in it, but there's no point in having the Go compiler in this image. Like for the image that I want to run, I don't need the Go compiler. I just need the Go compiler at build time. So let's create a multi-stage build and have the final image only have our built application in it. So for this, we're going to use what's called a static image. Now, the static image is very small. It does have a few things in it. So what it has in it is basically like a Unix file system, a temp directory, some certs for accessing stuff over SSL, or TLS, I should say, and not a lot else, quite frankly. Time zone information, maybe. So sort of the very minimal things that the average Unix application needs to work beyond a file system. So and then we're going to copy, and I'm going to go back to top line. We're going to call this first stage here as build. So this first stage here is the build stage. And the second stage here, in a multi-stage build, like each from line is a separate stage. So in the second stage, I'm going to say copy from the first stage, which is called build. I want to copy the binary, which should be at /work/hello. And let's just copy it to the root of the file system, which is /hello. And then I'm just going to set the entry point. We could delete the entry point above if we felt like it. And we'll just set it to /hello. And now there is one more thing I need to do. By default, Go won't necessarily produce a completely static binary. This gets into, I'll talk a little bit later about exactly what static binary is and levels of static binary, for want of a better word. But if I pass cgo enabled equals 0, in most cases, that will produce a completely static binary in Go. Not necessarily in all cases. There are some blogs you can look up that will explain some of the nuance around this. But basically what it's doing is it's telling the Go compiler to use the Go versions of libraries for talking to the kernel rather than glibc or muzzle. So that's what's kind of going on with cgo enabled equal to 0. Right, so let's save that. If anybody thinks I made a horrible error, now's the time to tell me. Docker build, and I guess we'll call it multi. Yeah, built, so it looks like I got something right. Again, there was cache, so that ran pretty quick. And I guess we should test it. I probably still got the old version running again. F8b. Right. And now we do docker run. Hello world. So still works, but what was it? No, I built the wrong image. Did anybody know? Did anybody tell me that? I should have done. Did I build the wrong image or did I build the right image and run the wrong image? I think I built the right image and ran the wrong image. So I'm going to stop that again, because I've not proved anything. Sorry, Docker RM -f. My only excuse is it's late here in the UK. And right, let's do this properly. So it's lab cg-multi. There we go. And now let's do the curl. Still works. So all still working. So it should still be 0 CVEs. We're using a smaller image, so less chance of CVEs, quite frankly. But let's double check. Also running the scan will be quicker. Like run the scan, starting the image, transferring the image. Because it's so much smaller, it's going to be a lot quicker. And how much smaller is it? A lot smaller. So now we've gone from gigabytes to 18 megabytes. So an absolutely enormous difference there. And that, is really quite big saving. And I would recommend that people do try to follow techniques like this, where you have a build stage and you copy the built binary into a different image to run it in. And of course, if you have a Java image or a Python image, you can copy from the Java JDK to build into like a JRE image to run, for example. Okay, I think that'll do for the demo. I will, if time allows, I'll do a short demo on debugging as well in a minute. But I'm going to jump back to the slides. Are there any questions at the minute before I jump back? No, we're good. Okay. Screen. Okay, so hopefully you can see that. Let's just flip back. Yep. So, yeah, I did update these results. Oh, one thing I should have mentioned is you can also run, like I ran with Gripe. You can also run with Docker Scout. Docker Scout support is a little bit different. So it supports a few less CVs, but if you run it now, you should see about 72 CVs. Yeah, but the big thing is we got down to 18 megabytes, which is an absolutely enormous saving from these two, and 0 CVEs. Oops, not too far. Yeah, so trying to explain a bit more about static and why I'm talking about static. So there's kind of two sort of binaries that you can build in the Linux world, at least. There's dynamic binaries, which link against other libraries outside the executable, and normally system libraries. So the vast majority of binaries on like your Linux system at the minute will link against, at the very least, things like glibc. That compares to static binaries, which are supposed to be fully self-contained. They don't link out to anything. Rust and Go code is typically statically linked in the sense that if for any sort of Rust library or Go library that you add to your project, that will be statically linked when you build it. Like, in Go, I think you always transfer the source code and it all gets built together. So you never link out to a Go library. It's always compiled into your executable, with the exception of system libraries in some cases. So if I hadn't written cgo enabled equals 0, it would have linked against glibc, I believe. Now, there's sort of two standard libraries on Linux. There's glibc and Muzzle. I mean, glibc is by far the most common. Like all the major distributions use that, with the exception of Alpine. So glibc is sort of considered the standard, if you like, but it has a drawback in that it's not very useful for static linking. It's quite difficult to do static linking with glibc. You compare that to Muzzle. It's basically an alternative for glibc, which can be used, can be statically linked. So it's quite easy to create an executable that contains Muzzle inside it. There are some concerns around Muzzle. It will have performance differences, so it's not the same. It's a completely different code base of glibc, so there will, of course, be some differences. And some people also have compatibility concerns because it will do things differently to glibc, or some things differently. but it should, in the vast majority of cases, it should be relatively similar in terms of performance and almost identical in terms of compatibility. It's just the 1% or 0.1% of things may cause you trip some people up. Okay, so we have variant images. So it's not just a static image, which does not include glibc at all. We have some images that include a sort of subset of the most common libraries. So there's two at the minute. The CC Dynamic, but that's actually not on the free tier. CC Dynamic includes glibc and libgcc, and then there's glibc-dynamic, which includes glibc, libgcc, and libstandard C++, which are all quite common libraries. FIPS. Yeah, so I'm always a little bit scared to mention FIPS, but FIPS is incredibly important for people in regulated industries that need to work with standards like FedRAMP, or standard's the wrong word. But in terms of FIPS, I'm not really covering FIPS at all in this lab. You are responsible for creating binaries and images which use FIPS cryptography solely. There is a go-FIPS image that you can get from Chainguard, and if you go to the page on images that Chainguard dev, you will find some advice there on using Go to create FIPS compliant binaries. And then there's also images like glibc OpenSSL FIPS, which includes OpenSSL configured to work in a FIPS compliant manner. So that's possibly useful in a multi-stage build. But yeah, please be very careful to make sure you're not accidentally bringing in crypto that's outside of FIPS, etc. Rust. So if you build in binaries with Rust, try the glibc dynamic image. I think that should work for the majority of cases, because your Rust binary should only link against libraries like those. If it doesn't work, there is a target you can pass to cargo to tell it to compile against muzzle. So like if you do cargo build and use a target like this, you will end up with a completely static binary. So I've used the word distroless, or you may have seen the term distroless used quite a lot. Basically, when we talk about distroless images, we mean images that contain the minimum number of dependencies. So or dependencies for the application to run. So if the application doesn't require a shell, for example, there will be no shell in the image. Quite often we'll find images that do require that for entry points or whatever, and those will have a shell. But if we don't need it, we will take it out. And the same with the package manager. You don't need APK or apt-get for your application that's running in production, so it shouldn't really be there in the image. However, we do have latest-dev images. So if you need the shell, the package manager, and in some cases other development tools, then you can use the latest-dev image, and that will have those. Yeah, so we've got a little bit of time. I'm going to do a brief demo on debugging distroless containers. Let me swap back and see if there's anybody. Oh, there's a comment. Stick to the same standard library for all. Yeah. You definitely have to use all muzzle or glibc. Mixing will end in horrible errors. I don't want to think what will happen. I suppose if everything's completely static, though, you'll be fine. Okay, I'm slightly scared how you found that one out, to be honest. Okay, let's go back to the terminal window. There we go. So debugging. What's it going to do? Right. So I think I probably still have this image running. Docker PS. Right, so we've got the labcg multi-image. To explain the problem that some people have with, or concern people have around debugging, a lot of people are used to running this. The Docker exec, of course I put the image name in when I meant to put the container name in. I didn't give it a name. So this is the problem. So you can't exec into the image because there is no shell to exec into, if you like. It's trying to execute /bin/sh, but that doesn't exist there. Neither does bash or anything. So I can't get a shell inside the container to poke at it, if you like. Now that's a good thing, or in my opinion, that's a very good thing, because it also means that attackers can't easily do it. Okay, it's really just making your system a bit safer in production. But of course, now and then you need to debug your images. My first recommendation for debugging would be just to, rebuild the image. If you're using something like Nginx or something like that, and you need a shell, which makes sense, you would use latest dev. Static image doesn't have a latest dev variant, so you'd probably use something like Wolfie Base, which is one of our smaller images. So if I rebuild with that, and let's start the other image. Let's give this a name so that I don't have to use it. Okay. Now, I've rebuilt it, so I should now be able to get a shell. Yeah, and there you can see my hello binary. And this doesn't make too much sense in this case because, what can I do with the hello binary? There's not much debugging I can do because this container is so small. I suppose I have confirmed that the hello binary is present, and who owns it, etc. So there are some users. Yeah, I should probably change the user from root to something else. Okay. What was the next thing I was going to show? Right. So if I go back and in a majority of cases, execing into a production container is probably a bad idea, and you should be thinking about other ways to debug. But if you do need to, you still can do it. So let's change this to static again. I should just start a second container. Right. Okay. No, stop typing things. Okay, so now I'll go back to the Docker exec. Did I give it that? Oh, I've not started again. Okay, there we go. Now Docker exec should fail again. But there are other tools you can use. So there's something called cdebug. There's also Docker debug. I don't have a pro license at the minute, so that's not going to work for me. If you do have a pro license, you will be able to do that. But there is a free version. So something called cdebug. If you have brew, if you're on the Mac and you have brew, you can just do brew install cdebug. I've already done this before, right? So I can do cdebug exec and then the name of my container. And this should get me a shell inside the container by side loading another shell, another container with a shell. So let's see if this works. I do have to pass the -- privileged argument in this case. Otherwise, you get an error message. Yeah, and so I'm now back in my container, even though that container does not have a shell because it's sideloaded the shell in. And it's also mounted the root file system, so I can see my hello binary there. Okay. Other thing that can be useful is Docker CP. So I can do Docker CP. Say, I was worried about that hello binary, or just want to check it existed. You could, of course, do something like, I hope this works. I think it'll work. Oh, debug test, what am I doing? There we go. And there you go. And I've run file here. So the file command is actually quite good if you're trying to create static binaries and figure out what's happening. So here I can see it's compiled for ARM, and it's been statically linked. And it still has debug info. Okay. So yeah, that's another way to do things without having to use cdebug. If you're on Kubernetes, there is a kubectl debug command, which is pretty useful. There is a little bit of a gotcha in that you have to specify a sort of image to sideload, and you'll want the user in the sideloaded image to match the user in the running container. Otherwise, sometimes you hit problems. But there isn't a flag to specify the user. cdebug does have a command to specify the user. kubectl debug doesn't. So if you're using kubectl debug on a disk-less image and you're having problems with permissions, you probably need to create an image with a matching user to the running image. So that in Chainguard container terms, what you can do is sideload the -dev image, if that makes sense, because the -dev image will have a shell in it. You can sideload it, but it will run as the same user as a latest image. Hopefully that kind of makes sense. It'll make more sense if you play with it, but yeah, that's getting slightly more complex. Okay, let me check if there's any questions. Yeah, that's a very good question. I hopefully talked about it a little bit earlier, but if the binary is fully static, can you not build the image on from scratch? Yes, maybe. What you'll find if you build from scratch, yeah, so that probably works with like this case, in most cases. Where it won't work is where your application depends on things, and it can be surprising what your application depends on. So the ones that I've hit are /temp directory. So if you have if you call like a method to create a temp file, for example, that actually assumes you have a /temp directory quite often. So you want a file system with /temp. Yeah, and TLS stuff, exactly. Yeah, so I mean, if you know your application doesn't need TLS, it doesn't need /temp, it doesn't need /etc, whatever, then yeah, go for it. You don't need the static. But the thing is, static's only, I don't know, 12 megabytes or so. So it's probably a lot easier to use static. I don't really think there's going to be any security implications from using static. So in most cases, I would just use from static rather than from scratch. But yeah, go for it. Use from scratch if you're confident. Hopefully that helps. Okay, back to slides. Unless let me check this. No. But that's a good question. Thank you. Yeah, so Docker, when you're debugging diskless images, be aware that you can use the latest -dev variant and just rebuild as that, or sideload the container with the latest dev. There is Docker debug. Yeah, ephemeral container. So in Kubernetes terms, kubectl debug is launching an ephemeral container as a side container. Yeah, and cdebug actually works across a range of runtimes. So it's not just Docker. It will also work with Kubernetes, nerdctl, containerd. So it's actually quite flexible. Cdebug is quite a nice little utility. Yeah, so I'm just going to wrap up now. Going back to how do we keep the CVEs out, or how do you keep CVEs out of your images? First thing is just cut down on dependencies. So the less stuff you have in your images, the less chance there is of having CVEs in there. Keep things up to date. I think that's actually probably a killer point, right? If you're very good about constantly updating your base images, constantly updating your libraries, that will go a long distance keeping things secure. I understand there's a tension between updating and things breaking, because like you pull an update, something's changed. So sometimes, it will break your application, which obviously you don't want. But, in those cases, I would say, well, yeah, you want a good test suite along with this. So a good test suite and update as much as possible. Yeah, and how we keep out CVs from our images, we can also issue security advisories. I realize that isn't going to be applicable to most of you. But it should be easy for all of you to change to Chainguard images, and there are major advantages, both in terms of security and in terms of size. There are a very large number of images available. If it looks like we don't have an image, please do ask, and we'll try and build it if at all possible, assuming it is open source. And yeah, there's -dev variants for the cases where you do need a shell and so on. Before I'll take any last questions, I do want to call out there is a learning lab on Chainguard libraries for JavaScript at the end of the month. I think it's in the same time slot as this one. So what we're building is Chainguard libraries. So rather than get your JavaScript libraries directly from npm, you can get them from us by configuring Artifactory or Cloudsmith or whatever you use to point to the Chainguard library. And our libraries are guaranteed to have been built from source, so there's no chance of sort of malware have been pushed to the npm library and us haven't got that. It will have been built from source and a verifiable trail back to the source. And also, we are starting to look at remediating CVEs, so actually fixing CVEs that turn up in various JavaScript libraries. So that should be a very interesting learning lab. I believe Manfred Moser will be taking it, and he can tell you a lot more then. He's closely involved in that product line. Yeah, so I think we can share these slides. There are a few other things you may be interested in looking at. Chainguard images directory is images.chainguard.dev. The Chainguard Academy, that's where my team is responsible for, and has a lot of documents and tutorials on various products, especially images or containers rather. There's also Docker debug and cdebug. And here's an article from Matt Turner on how to statically link Go applications. So this gets into all the like nitty-gritty, in which cases a Go binary will be statically linked or not. Because it's a little bit more complicated than you may realize at first glance. The very nice blog. Okay. And that's about it. I don't know if there's anything else. Otherwise, is there any questions? Yeah, so you're saying about Java. Yeah, we have Java. You probably know that. We have a JDK and JRE images, so you can do the same thing just when on JRE. Link plugin. Cool. Right, I will let you all go. Thank you very much for taking part. Enjoy your evening. Bye.